Welcome to Philtec's Basic Training Series, D-Type Sensors, Reflectance-Dependent Models. Subject number 2, D-Type Sensors with Digital Output. D models are commonly used for measurements to objects moving parallel to the axis of the sensors, as shown here. These sensors have an analog front end with near and far side regions of operation. And they have a digital back end that linearizes the distance output over the sensor's total operating range. Let's first examine the analog front end. D-model sensors have 3 regions of operation. The near side, with high sensitivity over a very short range. The optical peak, which is used for scaling of the sensor output to various targets. And the far side, with a long operating range and moderate sensitivity. Objects to be measured can vary from high reflectance mirrors to metals to very poor reflectors. The input amplitude of a D sensor is proportional to the gap distance to a target. It is also proportional to the amount of reflectance of a target surface. This graphic shows there is a very wide variation of input amplitudes from the most reflective to the least reflective targets. So, how can you make accurate distance measurements with your particular target material of unknown reflectance? The optical peak amplitude is used to calibrate the sensor to the reflectance of your target surface. With analog models, the sensor is calibrated to your target reflectance in 2 steps. Step A, move the probe to the gap that gives you the highest voltage. Step B, reset that peak to exactly 5.00 volts. Then, the factory supplied calibration chart can be used to accurately convert volts to distance. With digital sensors, the process is easier. Move the probe through the optical peak region and the peak is automatically captured. Now let's take a look at the digital sensor control software. We refer to digital sensors as displacement measurement systems, or just DMS. This is the opening screen of the DMS control software. When we open the COM port, the sensor is initialized and the grayed out tabs become active. To get started, click on the Configuration tab. There's an upper section with sensor controls, a center section with controls for the live graphical display, and a lower section for saving data to files. Capturing the optical peak. To capture the peak, start in contact with your target, or very close to it. Click on the peak hold button and slowly open the gap till it is past the peak value. In the reflectance peak window, the highest value captured is the optical peak, and the sensor is now calibrated to your target surface. After the peak has been captured, reset the sensor gap to the near or the far side for measurements to begin. You can refer to the Admin tab, where you can see a chart of the calibration data plotted. This particular sensor has a 10 mm operating range. A gap of 2 mm puts it in the middle of the steepest part of the slope, the highest sensitivity. A gap of 5 mm puts it in the middle of the far side operating range. So let's go back to the Config tab. And on the graph display, let's select far side distance. And let's clear the chart to reset it. And now we're going to set the gap to 2 mm, which is the highest sensitivity range. Alright, here we are at 2 mm. Now let's talk about sensor resolution. This table shows the D100 distance measurement limitations due to the internal noise of the sensor. ADC average, that equals the number of internal readings averaged before sending data to the PC. Internally, the sensor continuously reads target data at a clock rate of approximately 10,000 readings per second. The ADC average speed is selectable from the drop-down menu at Average. The peak-to-peak amplitude of the display chart is updated continuously right here. Here we are looking at the D100 noise signal, which is about 700 nanometers at the fast read speed of 2 averages. At the slow speed of 4096 averages, the noise signal drops down to about 100 nanometers. The final topic of this session is saving data to files. Beneath the live graph display, at distance units of measure, select either microns, millimeter, or inch units. In the log file window, browse to a location on your PC and name the file. The TXT file extension is the best, but any extension, or even none at all, will still allow a spreadsheet program to read the data. Data can be streamed continuously, or a fixed time delay can be used. For example, to record data once per minute, enter a delay of 60 seconds. To start data collection, click Save Data to File. Save data includes a universal timestamp, the sensor serial number, the temperature of the sensor amplifier, and the distance output of the sensor. That concludes this training session for D-model sensors with digital output. If you have any questions, please send email to sensors@philtec.com, or you may contact your local technical agent. To find your local agent, go to philtec.com/sales/salesmap.html.